Hi, in this video I will talk about the Gifford-Gibbs problem largest BST. In this problem we are given with a binary tree and we have to find the size of largest BST present in this binary tree. If I consider this tree as a given tree, then answer of this tree will be 6 because size of largest BST in this tree is 6, which is represented by blue nodes. So before going to solution part, let's see some properties of binary search trees. अकॉर्डिंग टू प्रॉपर्टीज ऑफ बाइनरी सर्च ट्री, अगर ये मेरा नोड है और उसका डेटा x है तो फिर उसके लेफ्ट सब ट्री में जितने भी नोड्स हैं उन सब का डेटा x से छोटा ही होना चाहिए और उसके राइट सब ट्री में जितने भी नोड्स हैं उन सब का डेटा x से बड़ा ही होना चाहिए और इस दोनों के साथ मेरा लेफ्ट सब ट्री और राइट सब ट्री भी इस प्रॉपर्टीज को फुलफिल करना चाहिए. So my binary tree called binary search tree if and only if it fulfills these conditions. Now let's move to naive approach, and in this naive approach I will traverse my whole tree, and while traversing I will check that my tree represented by current node is BST or not. If it is BST, then I will mark my answer and move ahead. But the time complexity of this approach will be big of n square. Instead of this approach, this problem can be solved in big of n time. So let's see efficient solution. In this efficient solution, I will write a solve function which will traverse a tree in bottom-up manner, and while traversing it will return an array of 4 elements. In that array, the zeroth index of that array will represent that the tree is binary search tree or not. First index will store minimum element in tree, second index will store maximum element, and the third index will store size of that tree. With help of this data of my subtrees, I will check that my current tree is binary search tree or not, and if it's binary search tree, then I will mark its size. So now let's go to C++ implementation, and after that I will do dry run for this tree. Here is my C++ implementation for same problem. In this implementation, first I will declare a global variable called ANS to store my answer. The code will start executing from largest BST function. In this function, first I will reset my global variable, and after that I will call to solve function. In the solve function, first I will check that my current root is null or not. अगर ये मेरा करंट रूट है और नल है तो ऑलवेज BST होगा, तो फिर उसका जो जीरोथ इंडेक्स है वो 1 कर दूंगा और उसका जो मिनिमम वैल्यू है उसको मैं इनफाइनाइट से रिप्लेस कर दूंगा और मैक्सिमम वैल्यू को 0 रख दूंगा, क्योंकि मेरा जो बाइनरी ट्री है उसका डेटा हमेशा 1 या 1 से बड़ा ही होगा और हमेशा नल ट्री की साइज 0 ही होती है, तो इसकी साइज 0 होगी. एंड इफ माई tree is not null, then I will call same function for left and right subtree and store its data into left and right vector. After that, I have declared the current vector to store the data of my current tree. Now with help of data of my left and right subtree, I will check that my current tree is binary search tree or not. So उसमें सबसे पहली कंडीशन ये थी कि मेरे लेफ्ट सब ट्री बाइनरी सर्च ट्री होना चाहिए और मेरा राइट सब ट्री भी बाइनरी सर्च ट्री होना चाहिए, और दूसरी कंडीशन ये थी कि मेरे लेफ्ट सब ट्री में जितने भी रूट्स है उन सब का डेटा मेरे करंट रूट से छोटा होना चाहिए. सो फॉर दैट आई विल चेक मेरे लेफ्ट सब ट्री में जो सबसे बड़ा रूट है उनका डेटा मेरा करंट रूट से छोटा है या नहीं. और नेक्स्ट कंडीशन ये थी कि मेरे राइट सब ट्री में जितने भी रूट्स है उन सब का डेटा मेरे करंट रूट के डेटा से बड़ा होना चाहिए. तो मैं ये चेक करूंगा कि मेरे लेफ्ट सब में जो सबसे छोटा रूट है उनका डेटा मेरे करंट रूट से बड़ा है या नहीं. सो नाउ इफ माई बाइनरी ट्री fulfills this condition, then it is BST. So for that I will mark this tree as a BST and calculate its mean and max value, and I will calculate its size with help of size of my left and right subtree. After that my current binary tree is BST, so I will try to update my answer. If my answer is smaller than my current size, then I will update my answer, and after that I will return my current vector to the parents. After executing this function, I will return my answer. So after executing this function, my answer will store maximum size of BST in my binary tree. Now let's do dry run for this tree. First of all, I will pass my this root to solve function, and here this root is not equal to null, so it will call to its left subtree. Here 11 will also call to its left subtree, and 8 will also call to its left subtree. Now control is come at 4, and 4 will call to its left subtree. That is null, so it will return 1, infinite, 0, and 0. Now control will come back to 4 and 4 will call to its right subtree. That is also null, so it will also return same. Now control will come back to 4 and 4 will check that 3 represented by 4 is BST or not. For that its left and right subtree must be BST, that is BST, and the maximum data in left subtree should be smaller than 4. Here maximum data in left subtree is 0, which is smaller than 4, and the minimum data in right subtree is infinite, which is larger than 4. So 4 is BST. So now 4 will make each vector that will be here size of this BST is greater than our initial size, which is 0. So I will update my answer and the control will come back to 8. Now 8 will go to its right subtree, which is 10, and the 10 will go to its left and right subtree. Both are null, so both will return same value. That will now with help of data of its right and left subtree, 10 will check that it is BST or not. Now here it is BST, so it will return here size of this BST is not greater than my answer, so I will not update my answer and the control will come back to 8. Now with help of these two data, 8 will check that the 3 represented by 8 is BST or not. For that its left and right subtree must be BST, that is BST, and maximum data in left subtree should be smaller than 8, that is smaller, and minimum data in right subtree, which is 10, should be greater than 8, that is greater. So 8 is BST. So now 8 will prepare its current vector, that will be 1, 4, 10 and 3. Here size of this subtree is 3, which is greater than my previous answer, so I will update my answer and control will come back to 11. Now 11 will call to its right subtree and 14 will call to its left subtree, that is null, so it will return 1, infinite, 0 and 0. Now control will again come back to 14 and 14 will call to its right subtree. Now 17 will call to its left and right subtree, both are null, so both will return 1, infinite, 0 and 0. Here 70 is BST, so it will return 1, 17, 17 and 1. Now control will come back to 14 and 14 will check that 3 represented by 14 is BST or not. For that purpose, each left and right subtree should be BST, that is BST, and minimum data in its left subtree is 0, which is smaller than 14, and maximum data in the right subtree is 17, which is greater than 14. So 14 is BST. So 14 will prepare each vector, that will be 1, 14, 17 and 2. Here my previous answer is 3, which is greater than 2, so I will not update my answer and control will come back to 11. Now 11 will check that 3 represented by 11 is BST or not. For that purpose its left and right subtree should be BST, that is BST, and maximum data in left subtree is 10, which is smaller than 11, and the minimum data in the right is 14, which is greater than 11. So 11 is BST. So now it will prepare each vector, that will be 1, 4, 17 and 6. Here size of this BST is 6, which is greater than my previous answer, so I will update my answer and control will come at 10. Now 10 will call to its right subtree and 12 will call to its left subtree. Now 14 will call to its right and left subtree, both are null, so both will return 1, infinite, 0 and 0. Here 14 is BST, so it will return 1, 14, 14 and 1. Now control will come back to 12 and 12 will call to its right subtree. Now 15 will call to its left subtree and 13 will call to its left and right subtree. Both are null, so both will return 1, infinite, 0 and 0. Here 13 is BST, so it will return 1, 13, 13 and 1. Now control is again come at 15 and 15 will call to its right subtree, that is null, so it will return 1, infinite, 0 and 0. And now with help of these two data, 15 will check that it is BST or not. Here For that purpose, its left and right subtree should be BST, that is BST, and the maximum data in each left subtree should be smaller than 15, that is smaller, and the minimum data in right subtree is infinite, should be greater than 15, that is greater. So 15 is BST. So now 15 will prepare each vector, that will be 1, 13, 15, and 2. Here my answer is 6, which is greater than 2, so I will not update my answer, and control will come at 12. Here I will continually check that it is BST or not. For that, its left and right subtree should be BST, and maximum data in left subtree should be smaller than 12. That is not, so 12 is not BST. So 12 will return by default data of vectors, that is 0, 0, 0, and 0. Now control will again come back to 10, and the 10 will check that the 3 represented by it is BST or not. For that, its left and right should be BST. Here its right subtree is not BST, so 10 will return by default data of vectors, that will be 0, 0, 0, and 0. After that, control will come back to largest BST function, and from that that function will return my answer, that is 6. So it is all done for these three. Hope you will like this video. Thank you.